The surface area of a square pyramid is given by the formula surface area equals 2 times b times s plus b squared, where b is the length of the sides of the base and s is the slant height. So looking at the square pyramid given here, again, because the base is a square, the length of each side of the base is b. And notice how we have 4 triangular faces, where each triangular face is also an isosceles triangle, and the height of each triangular face would be s, the slant height. If b and s are whole numbers, and the surface area is 56 square inches, sketch a possible base and a corresponding face of the pyramid. So we want to solve this equation here, where SA must be 56 and b and s must be whole numbers. Let's do this on the next slide, then we'll come back and sketch a possible base and triangular face. So to find our solutions, we'll substitute 56 for SA, we'll select a whole number value for b, and then solve for s. The reason we're selecting a value for b and not s is because b occurs in 2 different terms of the equation. So let's try b equals 1. Of course, b can't be 0, otherwise the surface area would be 0. So if b equals 1, we'd have the equation 56 for surface area must equal 2 times b, which we're saying is 1, times s, which is unknown at the moment, plus b squared, which would be 1 squared. So simplifying, we have the equation 56 equals 2 times 1 times s, that's 2s, plus 1 squared, which is 1. To solve this equation for s, we first isolate the s term by undoing this addition, so we subtract 1 on both sides of the equation. Simplifying, 56 minus 1 is 55, equals, on the right side, notice how we have 1 minus 1, which is 0, so we have 55 equals 2s. And now, because 2s means 2 times s, to solve for s, we divide both sides by 2. Simplifying on the right side, 2 divided by 2 is equal to 1, so we have 1 times s, or s. Here on the left, though, we have 55 divided by 2, which is not a whole number, because this quotient is equal to 27.5. So here, because s is not a whole number, this does not help us solve our problem, because both b and s must be whole numbers in order to satisfy the given conditions. So we try a different value of b. Let's try b equals 2. If b equals 2, we'd have the equation 56 equals 2 times b, which is 2, times s, plus b squared, which would be 2 squared. Simplifying, we have 56 equals 2 times s is 4s, plus 2 squared is 4. Next step, we want to isolate the s term by undoing this addition, so we subtract 4 on both sides. Simplifying, 56 minus 4 is equal to 52. On the right side, 4 minus 4 is 0, so we have 52 equals 4s. And now I think we found a possible solution. The next step, we divide both sides by 4. Simplifying, we have 1 times s, or s, on the right. And 52 divided by 4 is equal to 13. So notice how here both b and s are whole numbers, which means we found a square pyramid where the length of the sides of the bases is 2 units, and the slant height is equal to 13, and the surface area is 56 square inches. So let's go back and use this to answer our question. Because we found b equals 2, the base can be a 2-inch by 2-inch square, which would look like this. And because the slant height is equal to 13, notice how b is also the length of the base of the triangle, which again is an isosceles triangle. So we'll sketch a 2-unit base here, and because the height of the triangle, which is the slant height of the pyramid, is 13 units, or 13 inches, from here we'd count over 13 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And now we can form the corresponding triangular face. This is only one possible solution. While we're here, let's see if we can find a second possible solution. So we already tried b equals 1 and b equals 2. Let's try b equals 3. So if b equals 3, we'd have the equation 56 equals 2 times 3 times s plus 3 squared. Simplifying, we have 56 equals 2 times 3 times s, that's 6s, plus 3 squared is 9. Isolating the variable term, we subtract 9 on both sides. Simplifying, 56 minus 9 is equal to 47, equals 9 minus 9 is 0. So I have 47 equals 6s. Divide both sides by 6. Simplifying, we get 1s, or s on the right. But notice how 47 divided by 6 is not a whole number, which means this is not going to help us solve our problem. So we can go ahead and just stop here and say s equals 47/6, which again does not help us solve our problem under the given conditions. So let's try b equals 4. If b equals 4, we'd have the equation 56 equals 2 times 4 times s plus 4 squared. Simplifying, 56 equals 8s plus 16. Subtract 16 on both sides. 56 minus 16 is equal to 40. 16 minus 16 is 0. So we have 40 equals 8s. And last step, divide both sides by 8. And I think we found a second solution. Simplifying, we have 1s, or s, on the right. And 40 divided by 8 is equal to 5. So again, here we have both b and s are whole numbers, and we have a surface area of 56, so we found a second possible solution. Let's also sketch this one on the previous slide. We just found b equals 4 and s equals 5 does satisfy the given conditions, which means a square base would be a 4-inch by 4-inch square. And for the triangular face, the base is going to have a length of 4 inches here. And the height is going to be 5 inches because the slant height of the pyramid is 5 inches. So from the middle of this base, we'll count to the right 5 units. 1, 2, 3, 4, 5. And this would be what one of the triangular faces would look like. I hope you found this helpful.